Alright, part 2 of word problems with logarithms. The earthquake question. So we have the magnitude of 2, magnitude of 4, and we have to compare the intensities. So to solve this problem, we are going to use the magnitude of the earthquake formula. So this is the formula that will be applied here. I is the intensity of the earthquake that is measured, and I0 will be the intensity that will be equivalent to every case. So that is the benchmark value that would be the same for any type of a problem that involves this formula. So to find to compare those two intensities, we have to use that formula twice, and we have to represent this in form of two equations. So magnitude 1 has a value of 2, magnitude 2 has a value of 4, and each corresponding intensity will be called by I1 and I2 using the same formula twice. So this is what I mean by that. So let me put a pen here. So M1 is log to base 10 of I1 divided by I0. And the second equation, M2, will be defined as log I2 divided by I0. Please note that this quotient goes inside the logarithm. So knowing the value of the left side for each equation, we can create a system of equations and solve them, find how I1 and I2 compare. So from the first, the value of M1 is 2, so you show 2 equals, so this logarithm, I1 over I0, and 4, very much the same. Now intensity 2 this time, and divided by I0. So to find the relationship between I1 and I2, it would be practical to solve this logarithm. So we have to change this logarithm into your exponent. I want you to recall the following property. If I have log base A of B is equal to C, I can convert into exponents as A of base A to exponent C is equal to B. So this is something that we are going to use it to solve our equation. So from the first one, so the ratio I1 over I0 is equal to, now the base here is 10, so 10 squared. And from the second, I2 divided by I0 will give you 10 to the power 4. So to find I1, we have to simplify that equation. So I1 now is 10 squared, which is 100 I0, and I2 is equal to 10,000 I0. So how I2 and I1 do compare? So the second number is larger, so we would divide I2 over I1. So the ratio will be, now in the process you will see 10,000 I0 divided by 100 I0. So now you can see that I0 is gone, and we will say, therefore I2, intensity of the second earthquake, is 100 times as intense as the intensity of the first one. So this is how they compare, and this solves our question right here. So the second question now involves sound intensity, and the formula, the loudness formula here, is very similar to the earthquake formula. It's very similar. So we have two objects that produce different sound level. So the space shuttle 180 decibels and jet engine 140 decibels. So we need to figure it out how intensity of one compares with the intensity of the other. Very similar to the previous problem. The formula, however, is slightly different. So let me show you the formulas. No, I wanted to use letter L for the loudness. Okay, so L is equal to 10 logs I divided by I0. So I0, again, it is a common value that will be used, the same number that would be used for any type of problem that involves loudness and sound intensity. And the value of that is, although it's not important to know for this exercise, 10 to negative 12 watts per meter squared. So this is just the intensity that we can barely pick up by human ear. So the space shuttle loudness is 180. So this is 180. This is 10 log. And we are going to use I1 for intensity of this first object. And you can see that for jet engine with loudness of 140, the value of intensity will be denoted as I2 divided by I0. So to find the relationship between intensity 1 and intensity 2, all we have to do is to simplify the equation and solve it for I1, I2, and then create the ratio. So the first step, what do we do? Simplify. You see that 10 and 180 can be divided both sides by 10, similarly with this equation. Okay, so now the left side is 18 log Bogdan ratio, and 14 right here log I2. So did I have to replace I0 with that number? No, because in the process you will lose it, so it is not really that critical. So to solve for I1, as you remember from the previous page, you have to convert logarithms into exponents. So base 10, so 10 to exponent 18 is I1 over I0. Similarly here, 10 to exponent 14. So 10, just note that base 10 is not shown, it is understood that logarithm base is 10. So 10 to 14 is equal I2 over I0. Okay, so find I1 as 10 to 18 times I0. find I2 as 10 to 14 I0. So intensity 1 has a greater value because exponent is 18. So we will divide I1 over I2. So we'll have 10 and 18 I0 divided by 10, 14 I0. So now you can see that I0 is gone. And how do you divide when the base is the same? The rule says you have to subtract the exponents. So the ratio will be here 10 to exponent 18 minus 14, which is 4. So I1 over I2 is 10 to 4. So therefore I1 is 10,000 as in tens as I2. And that solves this problem. Thank you very much for watching, and see you next time.